a number called 1 1 in base 2. 1 1 in base 2. Now this can be understood by directly system, right? What is the its respective value that we need to understand as part of human being? What is this value? Any idea? This is 3. How we are getting the 3? So here you have to do something like you have to do some kind of calculation. So indexes are started with 0, 1, right? So you have to take the respective digit and you have to multiply with powers of the respective index position size 2 power 0 plus 1 into 2 power 1. If you are able to calculate this will be 3. That is the decimal number system format. Okay, now fine. For example, let us take one more example. 101, which is in base 2 format, you need to calculate its respect to decimal format. What you have to do? You have to take the first digit 1, that should be multiplied with the powers of 2, 2 power 0 plus 0 into 2 power 1 plus 1 into 2 square, which is the value is 5. 5. So the respective number 101 binary is equivalent to 5 in decimal number system, right? So meaning that we are trying to convert binary number to decimal number. So there are many kind of conversions are there which is needed for us. Among those, one kind of conversion is any number system to decimal number system, right? So I have shown example from binary to decimal number system. For example, try to observe, I have taken the same 1 1. I am assuming that this is available in octal number. Is the value is same or different in decimal? Different, because its internal logic is completely different, right? So how we are going to do it? The process same. 1 into 8 power 0 plus 1 into 8 power 1, which you are going to get as 9 in decimal number. Okay, fine. I am trying to take the same number 1 1 in assuming that this should be an hexadecimal number. Hexadecimal number. What is the respective value in decimal number? 17. 1 into 16 power 0 plus 1 into 16 power 1. So answer is 17. 17 will be equivalent in decimal number system to 11 in hexadecimal number system, right? So sometimes you may observe the actual integer values as 11 like that. Sometimes you may observe fractional parts also, right? Fractional parts means something like 11.01. Can I take it as a binary number? Is it valid or not? Because all values are less than 2 only. So it is a valid binary number, right? At this time, how we are going to calculate? Right? So basically, numerical part, right? So if you observe here, this index is 0 and the remaining left, while moving to the left side, index position is 1 and so on. Similarly, here the index position is -1, -2 and so on. While moving to the left side it should be plus and while moving to the right side it should be minus. So how we are going to calculate this one? The same procedure. First try to calculate the numerical part, I mean positive section part. 1 into 2 power 0 plus 1 into 2 power 1 plus find out the negative part. 0 into 2 power -1 plus 1 into 2 power -2. What is the value? So I think you are going to get here 0, right? 0 into 2 power -1 is 0 and 1 into 2 power -2 is 1 by 4. 1 by 4 means 0.25. So total value is I think 3.25. 3.25. So 3.25 is the decimal number system equivalent to 11.01 in the binary number system. So like this you are going to follow the same procedure, right? Okay. So another kind of situation. So this is for understandability. What about system understandability? If I am going to give any kind of decimal number system, we can able to convert into any number system. right? Any number system means it can be binary, octal, hexadecimal, or with base radix 6 or whatever it may be. It can be any other thing, right? How we are going to do that? For example, try to take out the number 3 only. Try to take out the number 3 only. Are you going to get the value 1 1 or not? Check. Right, 3. Right? How we are going to get it? Right? See, observe here. I am trying to convert 1 1 into 3 by simply performing multiply with 2 powers of something. Right? If you want to get back the same number, what you have to do? Opposite to that one, right? Once you are trying to perform multiplication, you are going to get something. If you want to get back, you have to simply perform division operation, right? So 3 should be divisible with 2. Divisible with 2. So why I am trying to convert to 2? Because my requirement is 3 base 10 to, I need to convert it to 2. So what you can do? 2 ones are 2, remainder is 1, and 2 zeros are 0, remainder is 1, right? So like this you have to calculate until you will get the remainder 0, or which cannot be solvable, right? So if you are going to write this in the reverse order from bottom to top, that will be as the respective number system data, right? Are you getting the same data or not? Yes, right? 1 1 base 2 is equivalent to 3 base 10, 3 base 10 is equal to again 0 1 1. Is there any value for this 0? 0 into 2 power 2. 0 into 2 power 2 is again 0 only. There is no problem. So meaning that when you are trying to convert decimal number system to any number system, what you have to do? You have to divide the actual number with the destination number system successfully until you will be solved it. Will be solved it, right? So for example, I am trying to take the same number like 5 base 10. Try to do it 5 with the 2. 2 2s are 4. You are going to get the remainder 1. 2 ones are 2, you are going to get the remainder 0. You can able to stop here because further it is not solvable, or else if you want you can able to do that 2 zeros. So if you write 101 respect number, right? Similarly, I want to convert the decimal number 9 base 10 to the octal number, sorry, octal number only, right? So what is the destination number here? 8. So you have to divide the number 9 with the octal number 8. 8 ones are 8, remainder is 1. So we can stop here. Yes. So that is 1 1 to the base 8. Similarly, 17 to the base 10. 17 should be divided with 16. 16 ones are 16, remainder is 1. Again, you are going to get 1 1 only. Right? So like this, you can able to take any number. For example, I am trying to take one number as 252. 252, which is in decimal number system. I am trying to convert it into octal number system. How can you do that, ma? Simply divide it with 8. If you are going to do that, 8 3s are 24, 8 ones are 8, remainder is 4. Okay, next 8 4s are 28, 8 4s are 32. So by observing your face, I am getting clumsy. 8 4 is 32, 8 3s are 24. 24, remainder is 7. Can we stop here? Yes, right? So this is the corresponding octal number for the decimal number 252 base 10. So what you are going to get here? 374 base 8. Can we check whether it is correct or not? Yes. All the digits whatever available here, those should be less than it. Those should be less than it. Or else you can simply perform again back step. 374 base 8 should be converted to decimal number. Then you can able to get the 252 base 10. Right? So what about this one here? If we take 3.25 base 10 to the again binary number system, right? So what you can do? First try to complete this integer part 3. What is the respective binary value for the integer part 3? You have already calculated, right? 3 for 3 you are going to get 011. For numerical part you are trying to do 011, and you have to take out the fractional part, that is 0.25, right? That should be multiplied with respect to destination number system. Again 0.25 into 2, 0.5, right? Take out the numerical part, I mean take out the integer part, that is 0, right? So you can able to add here, after point you can able to add this 0. Okay, next what is the remaining after removing this one? 0.5 into 2, are you going to get what? 1.0. Then what is the next digit? 1. If you remove the 1, what is the next value here you are going to get? 0.0. 0.0, that is going to multiply with 2, you are going to get 0.0. Again you are going to take 0. This process is going to continue. You are going to process it. Again you are going to get only 0. So we can able to stop here. Like, so take out the simple another example. For example, I am trying to get, okay, 2.96, 2.96, which is in decimal format. I am trying to convert it into binary number. What you have to do first? First you have to take out the integer value. 2 should be divided with 2. 2 ones are 2, remainder is 0. So 1 0 is the one kind of part, right? Try to note down 1 0. After that you have a dot, place the dot, and trying to take 0.96 should be multiplied with 2. 0.96 should be multiplied with 2, right? If you are going to multiply with 2, what is the value you are going to get? 0.96 into 2, you are going to get 2 6 are 12, 2 9s are 18, that is so 1.92. In this integer value is what? 1. So trying to take out the integer value 1 and place here. If you remove the integer value, what is the remaining value here? 0.92 into again 2, again 2. So you are going to get here as 4, 1.84. So take out the 1, you can place here 0.84 into 2, again 1.68, I think. So again 1, again 1. So like this you can able to enumerate this, or you can able to stop a maximum of 3 digits, right? So the binary respective value for 2.96 base 10 is 10.111, 10.111, right? So this way you can able to convert decimal number system into another kind of number system. Okay. So meaning that, so we have seen the procedure for converting any number system to decimal number system, and another one is decimal number system to any number system, right? So we'll see one more kind of conversion, which is for our calculation is very easy. One is octal to binary number system, right? So if somebody asks you to convert 756 base 8, octal means base 8, is it a valid number? Yes. Into the respective binary number 2, right? So what is the simple solution? What we can do according to what we know? Can we convert first into? Can we convert first into? If you are going to convert octal number into binary number, according to our existing solutions, we have already know the logics, right? Any number to decimal, decimal to any number. First, what we can do? Any number to decimal number system we can able to follow. Yes or no? First, I am trying to convert into decimal number system. From decimal number system to, I can convert this. This is a simple logic. You have to follow the same procedure in order to solve any kind of gate questions, because those questions are very complex, right? So what you can do? Try to calculate 76 base 8 in decimal number system. So first value is you are going to get 6, second is 40, third is 64 into 7. What is the value of 64 into 7? 448, right? So What is the value? 494. Is it correct? Right? 494 in decimal number. Right? Now this decimal number you need to convert into again binary number. So what you can do, simply 494 is going to divisible with 2. So you can able to process it and trying to get back, writing down the numbers from bottom to top, you will get the actual binary number, right? So try to calculate. 2 2s are 4, 2 4s are 8, 2 7s are 14, 0, 2 1s are 2 2s are 2 3s are 1, 2 6 are 12, 2 1s are 1, 2 3s are 2 zeros 1, again 2 15s are 0, 2 7s are 1, not 2 7s are 1, its remainder is 1, 2 3s are 6, remainder is 1, 2 1s are 2, remainder is 1. So your answer will be, so try to cross check, 4 ones 0, triple 1 0. Is it correct? Yes, right? So this is the way you can able to calculate. This is the one simple solution what you have to do, right? So or else try to observe, I am trying to extract some features, right? If I am trying to say a number as octal number, what are the digits possible for an octal number? 0 to 7, right? 0, 1, 2, 3, 4, 5, 6 and 7, right? So if I am trying to have these numbers, so how many digits are required to represent the number 7 in binary format, right? We are trying to extract it for binary number system. Binary number 7 ni binary, 7 number ni binary number lo ela represent chestamu? Triple 1. Can we represent it in the form of triple 1? Yes or no? Right? How we are doing that? Powers of 2. 2 power 0, 2 power 1, 2 square. Right? So when you are trying to convert any number into binary number, simply we are going to multiply the number with the corresponding location number with the index number. Right? So if you observe now, 1 into 2 power 0 is 1, 1 into 2 power 1 is 2, 1 into 2 square is 4, 4 plus 2 plus 1 is second. Again, are we going to get the number 7 or not? Similarly, if you want to get the number 0, what you have to do for these three places? 0 0 0, right? So similarly I can write like this: 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 1 0, 1 1 0, right? Now observe the 756 base 8 you have here, you need to convert it into the respective binary number system, right? So as these numbers I can able to directly represent, can we take the 7 and can I write this alternative number? 7 I can write as triple 1 and 5 I can write as 101, 6 I can write as 110. So are we getting the same data or not? Yes. This is the way I can able to, right? So meaning that when you are in octal number system, what is the maximum number of digits required to represent a number? When you are in octal number system, what is the maximum number of digits required to represent a particular number? 3 digits are enough, right? Right? Can we able to represent the number 8 with the help of 3 digits? No, it is not possible. If you want to represent one more number, more than 7, you have to compulsory add 4 digit number. If you are going to place 4 digit number, it should be zeros. Is it okay? It should be zeros. And what about the 8 value? 2 cube is 8 and all the remaining are, right? So like this, what is the maximum number I can able to place with respect to a 4 digit number, 4 digit binary number? 15. If I am going to place all the numbers with 1, 1 1 1, 2 power 0 into 1, 2 power 1 into 1 and so on 4 times, you are going to get the value 15. So try to observe here, with the help of a 3 bits, with the help of a 3 bits, I can able to generate a maximum number 7. With the help of a 4 bits, I can able to generate a maximum number 15. Generate a maximum number 15, right? Similarly, if I am going to have an n bits, I am going to have an n bits. What is the maximum number I can able to generate? 2 power. Is it okay with 2 power n minus 1? So 2 cube minus 1. Okay, 2 power 4 minus 1. 15. Is it okay? What about for the n value? For example, try to assume for the 5 bits. If it is for 5 bits, 2 power 5 minus 1. 2 power 5 minus 1, that is 32. 1 minute. Cool. That is 31. Right? If it is 31, are you going to get 31 for the 5 consecutive ones? Yes or no? Try to calculate. This is 2 power 4, 2 cube, 2 square, 2 power 1, 2 power 0. 2 power 4 is 16 plus 8, 24. 24 plus 4, 28. 28 plus 2, 30. 30 plus 1 is 31. Right? So if you would like to represent an n bit, if I am having a space of n bit number, n bit space, I can able to generate a maximum of 2 power n minus 1. This is important. 2 power n minus 1. Okay, fine. Similarly, if I am going to have, a binary number, I am asking you to convert into again an octal number. What you can do? Again, you can go for a decimal number followed with again octal number. Instead of that, what we can do? According to our logic, what we can do? Every three numbers, I can be considered as a one digit in octal number system, right? So try to take out 110. What is the value of 110? 6. What is the value of what is the value of 101? 5. What is the value of 111? 7. 756 base. Like this you can able to calculate, right? For example, some you got like 354.26 in base 8. I am asking you to convert it into binary number. What is the simple solution? First, is it a valid octal number? Yes or no? Yes, right. 4 I can represent as 100. Why I am going to take only three digit number? Why can't I add 0, one more 0 here? Because they are asking for only octal. Octal requires 3 digits. 5 means 101, 3 means 011 dot, 2 means what? 010, 6 means 110. This is the representation in binary number. Binary number, right? Now again getting back to the again octal number. For example, instead of octal number, they are asking for you to convert into hexadecimal number. Hexadecimal number, meaning that uh, binary number to hexadecimal number. What you can do here? You can simply take from point, you can start 4 you can consider. Why I am trying to consider it as 4 because hexadecimal requires maximum of 4 digits, right? So here you can able to append 2 zeros. There is no problem because on the right side for fractional part there is no problem. Similarly for the integer part on the left side there is no problem. There is no value for it, right? Here you can able to segregate like 4, right? What is the value of 1100? 8 plus 4, 12. 12 means 12 means C. 12 means C, right? What about 1110? I think 14. 14 means E. 14 means E. What about the right side? 5. 101 is 5, right? 5. 1000 means, so EC dot 58 is in hexadecimal number system, right? If somebody tries to convert this into again a binary number, what you have to do? You have to take out every number comes with the 4 digit, not 3 digits, because it is a hexadecimal number system. Like this, you can able to convert. One more kind of thing is hexadecimal to binary number system. I think I have covered here, right? So because we can able to take 4 is one part, you can able to get it, right? What is another one we have covered here? Directly we covered octal to hexadecimal, hexadecimal to octal number, hexadecimal number to octal number, right? So you can able to solve any kind of question if somebody has asked the questions of conversions.